Look out at the cosmos. Billions of galaxies. Trillions upon trillions of stars. And one profound question: is anyone else out there?
We want to find another Earth. Is there a pale blue dot orbiting some star out there in the galaxy?
The search is on for worlds that could harbor life.
We're searching for our own vision of ourselves out there in space. We're searching for our heaven.
We've already discovered more than 700 planets beyond our solar system. And yet these exoplanets look nothing like our own.
Boy, were we wrong. All these solar systems that we're seeing in outer space, we find that they don't look like our solar system at all. We are the oddball. We're the freaks.
These are nightmare worlds. And the cosmos is full of them.
We're finding all different flavors of hell, all these different ways that planets can go wrong. So that's where we are right now, searching for heaven, finding hell.
These are worlds where life couldn't possibly survive. Could we really be alone? A cosmic fluke in a universe hostile to life? We may soon have the answer.
Now we have discovered hundreds of exoplanets in outer space at the rate of over 1 exoplanet a week.
In a few years, that will probably be thousands. And in the end, there could be millions or even billions of these things waiting for us to discover them.
How could all of them be planets from hell? The quest for answers starts here, 63 light years from Earth. We've discovered a planet. It's even larger than Jupiter. And it has a serious problem. Its orbit is incredibly tight. It's closer to its star than Mercury is to our sun. And 30 times closer in than the Earth. The result is a superheated hell. But there's another reason why nothing could survive here. And that's the ferocious wind. The surface is battered by a never-ending storm. We can't see these winds with our telescopes. But we know the superstorm exists. Because of this. NASA's Spitzer Space Telescope. Spitzer can see things that we can't. It doesn't use visible light. Instead, it sees in infrared. It's a part of the light spectrum we don't see with our eyes. Infrared is heat.
One advantage of studying the universe in the infrared is it gives us this opportunity to see the light coming from planets around other stars. When you try to look at the light of a planet next to the light of a star, the star is hundreds of thousands of times brighter than that planet, which renders the planet very, very faint. But if we push into the infrared part of the spectrum, the internal heat of the planet, just as my internal heat, causes the planet to glow. Now it's observable and measurable.
Spitzer gives us something completely new. The very first weather map of a planet beyond our solar system. This simple image is a technological triumph. The colors represent temperature differences. But the map also proves the planet has hellish winds. That's because the hotspot isn't where it should be. One side of the planet permanently faces the star, so its center should be the hottest point on the planet. It isn't. Something pushes the planet's hotspot to the side, and that takes incredible force. Only a non-stop 6,000-mile-an-hour hurricane could be this powerful. "20 times stronger than the strongest winds on Earth. 8 times the speed of sound. A small shift on a weather map. Evidence of supersonic winds raging on an alien planet. Truly, a planet from hell. We're finding new planets at a staggering rate, an average of 1 a week. Each one could be an Earth-like heaven. But the more we explore them, the more hellish worlds we find. And some are so nightmarishly hot that they're more than uninhabitable. They shouldn't even exist. This Jupiter-sized gas planet is 256 light-years from Earth. In infrared, it shines like a star. Thousands of times brighter than Venus, the hottest planet in our solar system. It's a blistering 3,700 degrees. It's nearly impossible for a planet to get this hot. Its hellish temperature provides a clue to its appearance. Only an absolutely black object could absorb enough light from its star to reach such scorching temperatures.
If you were coming up on the night side away from the star, you would just see this blackness in front of you. Very little radiation, very little light. It would almost just look like the stars were avoiding a part of the sky.
Just as black pavement absorbs sunlight and heats up on a sunny day, the black planet roasts beside its star. We don't understand its atmospheric chemistry. There's nothing on Earth that can absorb so much light. The planet's only color comes from a scorching hotspot.
As you flew around to the day side, things would begin to glow red hot. There'd be a huge swirling storm, all red and glowing. What a hellish world.
Deep inside, clouds of titanium oxide swirl around a solid heart, 100 times heavier than Earth. Darkness visible, another world from hell. But some planets are even bigger, seemingly impossible puzzles.
Here's a mystery. Every astronomy textbook says that gigantic Jupiter-sized planets form way out in outer space where it's really cold. So why is a Jupiter-sized planet, what's it doing inside the orbit of Mercury?
Jupiter-type planets can only form far from their parent stars, out in the cold of space. A gas giant orbiting this close means these monsters can move. This is WASP 12b, a scorching vision of hell. It's so close to its star that its orbit lasts just one Earth day.
This world is so hot, it's over 4,000 degrees Fahrenheit. This is just crazy hot.
WASP 12b is one of the hottest planets in our galaxy.
We've never seen anything like this before. This certainly is one of the most violent environments in the universe.
WASP 12b is only 2 million miles from its star. Searing heat puffs up its atmosphere, giving it the density of styrofoam. In a big enough bathtub, it would float.
We actually think it's so close to its star that the gravity, the tidal effect of gravity, warps it into almost an egg shape. It's not even round, it's oblong.
Thousands of miles beneath the puffed up atmosphere lies a solid core. It's rich in carbon, and the pressures are extreme. There could be mountains of diamond and graphite, and seas of liquid tar. But WASP 12b won't last long. It orbits so closely that its star is literally tearing it apart, ripping away nearly 190 quadrillion tons of gas a year. "10 million years from now, WASP 12b will vanish. The question is, how did it get so close in the first place? This is the birth of a solar system. In the center, a new star. Around it swirls a disk of microscopic dust grains. These are planets in the making.
The dust grains collide, and every time they collide, they merge, and so they get bigger and bigger, and so they sort of grow like the dust bunnies under your bed. And you have 100,000 years or 1,000,000 years to make a very big dust bunny, and they get bigger and bigger and bigger.
Trillions of miles from the star, it's cold enough for ice to form. Ice picks up dust and gas, these gaseous clumps grow bigger and bigger over millions of years. Eventually, they become gas giants. In our solar system, the gas giants, Jupiter, Saturn, Neptune, and Uranus, all form this way. In the distant orbits we still see today. So how did WASP 12b end up so searingly close to its star? The answer? Gravity. This planet is huge, 40% more massive than Jupiter. Its immense gravity disturbs the dust disk it formed from, creating turbulence.
And so the planet creates waves in the disk, sort of density waves. And you can sort of think of them as like waves on an ocean.
The gas giant becomes a galactic surfer. Over hundreds of thousands of years, the planet rides the waves inward toward the star.
As the planet gets closer and closer to the star, it starts to feel the radiation from the star more and more, and so it heats up.
Surfing millions of miles from the cold outer reaches of the star system into the tight, scorching orbit we see today. An ice-cold world becomes a planet from hell.
Nobody had any real clue that you could form a planet 1 billion miles out from a star. It somehow moved in. That is incredible, but that's really the only explanation of how these planets got so close to their stars in the first place.
WASP 12b is bizarre, but it isn't alone. We've found many of these super hot, super close giants. We call them hot Jupiters. Battered by supersonic winds, blacker than night, hotter than hell. But these hot Jupiters all have one thing in common. There's no life here.
So these planets are just about as different from the Earth as you can possibly imagine.
In fact, we've now found over 100 of these things, rendering them so common that the question really emerges, which ones are the weirdos, them or us?
This planetary roller coaster has consequences. As they spiral inward, hot Jupiters cause chaos. They create a whole new class of planets from hell. Orphan worlds flung away from their star into the emptiness of interstellar space. Planets orbit stars. Between the stars is a vast sea of darkness.
We've always thought of space as being empty. That would be considered its defining characteristic. That's why we call it space.
But when planet hunters switched from gazing at stars to staring deep into space, they made an amazing discovery. Out of the darkness, between the stars, planets began to appear. First, one dark gas giant. Then several more. Eventually, 10 dark, starless planets emerged from the shadows of space.
often wonder what it would be like to be on one of these rogue planets in between stars. The night sky would be perfectly black. It'd be festooned with stars. It'd be beautiful.
But if you were at one of these planets, you would be in a world of perpetual night. There would be no sunrise or sunset. There would be no warmth of the sun.
These planets formed around a star, but now they roam the darkness of interstellar space. Their journey here was violent, each one forced from its home orbit by the gravity of a hot Jupiter.
A Jupiter-sized planet is an 800-pound gorilla. Where does it sit? Anywhere it wants to.
Hot Jupiters are killers. As they surf in toward their star, their immense gravity disrupts the system. Hurling planets from their orbital paths.
It flings into outer space any small planet. So any planet unfortunate enough to be orbiting close to the mother star would be flung into outer space with a passing Jupiter.
These planets will never again feel the heat or see the light of a star. All the rogue planets we've found so far are gas giants, but perhaps there are smaller, rocky worlds too. Worlds that were once like Earth.
The large Jupiter-like planets are just easier to see, but there's no reason to assume there also aren't smaller orphan planets. Maybe as a Jupiter planet moves in toward the star and plays ping pong with the planets, even something like Earth could have gotten kicked out. Then you would have this cold, frozen little world, just streaking between the stars, dark and lonely.
These planets are victims of a violent gravitational battle. Frozen, orphaned Earth twins.
There may be hundreds of billions with a B of these planets roaming the galaxy. Now, there are only a couple of 100 billion stars in the galaxy, so that means these rogue planets may actually outnumber stars.
Right now, we find an average of at least one new exoplanet a week. As our technology improves, we'll see smaller and smaller planets orbiting stars, worlds with a solid surface like our own. But the first rocky planets we've found are nothing like Earth. These planets have been to hell and back. We have found hundreds of alien worlds. And now for the first time, we're finding small planets made of rock, just like Earth. Planets this size are potential homes for life. But instead we find more planets from hell. Weird, nightmarish, and uninhabitable. This is Coro 7b. A world of violent extremes. Two hells in one. It's so close in that its star looms 360 times larger in the sky than our sun. On Coro 7b, the first hell is unimaginably hot. The surface is a furnace, roasting at 4,700 degrees. Lava boils, turning the atmosphere into vaporized rock. When a cooler front moves in, small pebbles condense, and rocks rain from the sky.
If that's not a classic vision of hell, I don't know what is.
But that's only half the story. The hot side of the planet is locked, permanently facing the star. Beyond is the twilight zone. It's temperate here, cool enough to turn the lava oceans into solid rock. But this pleasant zone is narrow. Travel further, and you descend into a second hell. This is the dark side. The half of the planet that never sees the sun. Eternal darkness and savage cold. The temperature is hundreds of degrees below zero.
So one side is hot, another side is cold. You either have, fire or ice in the extreme, the coldest places in the universe and the hottest places in the universe. You couldn't think of a worse place to end up.
The planet was not always this way. Turn back the clock 1.5 billion years. Coro 7b is forming. But it isn't rocky. It's a gas giant, 100 times bigger than Earth. It migrates in toward its star. As it closes in, the star blowtorches gas from the planet. Its gaseous shell blasts off into space to reveal a rocky core. Coro 7b is the skeletal remains of a hot Jupiter. Its parent star has reduced this once massive gas giant to a rocky cinder. It's hard to imagine planets more extreme than Coro 7b. Yet they do exist. Rocky worlds, machine gunned by deadly cosmic rays. This is a pulsar, 7,000 trillion miles away from Earth. It's a kind of cosmic lighthouse. This unbelievably tiny world, just 10 miles across, fires an intense beam of radiation through space as regularly as an atomic clock.
A single cubic centimeter, the size of a keyboard key, actually has about as much mass as Mount Everest. Smash a Mount Everest into a cubic centimeter, the whole star, which is only about 10 miles across, is like that.
It's one of the most hostile environments in the universe. Anything nearby gets hammered by intense gravity and magnetism. No one expected to find a planet here. But this pulsar has 3. Small, rocky, near Earth-sized. They were the first exoplanets ever discovered, and the last place you would ever find life.
It's got a tremendous magnetic field. It's blasting out X-rays. So these poor planets are just getting cooked by radiation. The word Earth-like, I don't think could be applied to these guys at all.
The X-ray beam strafes the planets over and over, firing radiation 1,000,000 times more deadly than medical X-rays. Slowly stripping their surfaces away. These are sterile worlds.
Everybody admits there's no chance for life, at least as we know it, on the planets that orbit the pulsar.
Radiation cooks pulsar planets to death. The opposite hell is no better. Frozen worlds too cold for life. In the constellation Scorpius, 20,000 light years away, is a red dwarf star. Red dwarfs are tiny and relatively cool. And this planet is too far away to fill what little heat there is. It's so distant, its orbit lasts 10 Earth years. It's the coldest planet we have found in the universe. Its surface is a frigid 370 degrees below zero. This is a world made entirely of ice. Methane, ammonia, and nitrogen are gases on Earth. Here they form a frozen, toxic frost. Glaciers and canyons and cliffs of ice are the only terrain. Here, hell really has frozen over. Our search for Earth's elusive twin reaches another dead end. Perhaps we are truly alone. Or will our first tantalizing glimpses of an alien world, potentially perfect for life, change everything? Earth, the only habitable world in our solar system. But in a galaxy of hundreds of billions of stars, can we really be alone? It's a question that planet hunters are trying to answer.
The whole purpose, in my opinion, of the discovery of exoplanets is to establish our true place in the universe. Who are we? Where do we belong in the cosmic scheme of things? Are there other planets that can have life just like ours?
That's where NASA's Kepler Space Telescope comes in. Kepler lets us calculate how far a planet is from its star. That's critical in figuring out whether it could sustain life. Life on Earth is only possible because we're the perfect distance from the sun, not too hot and not too cold. Just right for liquid water, oceans, rivers, lakes, rain, and life.
You know, journalists say, follow the money. Astronomers say follow the water, because water is the universal solvent that dissolves most chemicals, and that's where DNA got off the ground. And where there's liquid water, there could be life.
We're looking for planets that are not too close to their parent star, where all the water would boil away, and not too far away from their parent star, where all the water would be tied up in a frozen form. We're looking for that Goldilocks zone, where the temperatures are just right for liquid water to pool on the surface.
Once Kepler has identified a new planet, astronomers check whether it lies in the habitable zone of its parent star. So far, Kepler hasn't found a single confirmed Earth twin. But it has identified more than 2,000 planetary possibilities. And it's this sheer abundance of planets that gives scientists hope.
The important thing to remember is that even though we're finding all of these terrible planets that are just completely unlivable, is that we're finding lots of them. We're finding hundreds and thousands of these planets. And what that's telling us is that planets are easy to make. And that means that even rare things are probably out there in large numbers. Even if the Earth is a rare, precious jewel in our galaxy, there may be dozens or hundreds of them out there.
Kepler has opened our eyes to a universe full of planets. We can now guess at how many there might be in our own galaxy. 50 billion. 50 billion worlds just waiting to be discovered. And we think 1% could be in the Goldilocks zone of their star. That's 500 million planets, each with a chance of harboring life. Right here on our own doorstep. We haven't found one yet, but we're getting closer. This is Gliese 581. A red dwarf star 20 light years from Earth.
Gliese 581 is a tiny little star. If the sun were the brightness of about a 100-watt light bulb, then Gliese 581 would be like a little Christmas tree light, a tiny little fairy light, very, very small. This shifts the life zone in, because now if you want to be warm enough, you need to snuggle up right next to the star.
The star has 4 planets. 3 are too close and hot for liquid water. But the 4th is different. It's a rocky world twice the size of Earth. And it's right on the edge of the Goldilocks zone. In theory, if the planet has a thick carbon dioxide atmosphere, it could trap enough heat to have clouds, rain, and oceans. It would be a strange place to live, twice Earth's gravity, bathed in permanent red twilight. But right now, this weird world is the closest we have to a planet like ours. It's a promising start.
When we actually know for a fact that up there around that star is a planet like Earth, that's going to just fundamentally change how people look at the sky and how people perceive their place in the universe. So that's going to be a profound moment, not just for me, but I think for humanity in general.
Our Our goal is to find another Earth, but along that path, we are going to find more things than we could have ever possibly imagined. And that's the part I love about this the most. We don't know what craziness is going to be around the next corner when we're looking for more planets. I can't even imagine.
Two decades ago, the only planets we knew were right here in our solar system. Now, there are hundreds, all very different from our home. The universe is filled with hellish worlds, super hot, ultra cold, violent, and bizarre. But the universe is also unimaginably vast. With so many stars, there are probably countless Earth-like heavens. All we have to do now is find them.